Hello, everyone. This morning we have invited Jonas Bengtsson and Ken Lunty from the Edge Environment Proprietary Limited to discuss one of the most interesting but complex topic, life cycle thinking. And life cycle thinking is at the forefront of infrastructure development, particularly making infrastructure sustainable. So thank you very much for coming along to share your expertise, and which is so invaluable to our students and to all of us. So let me ask Ken, just tell us about the edge environment and the experience that you have in working on life cycle assessments and developing life cycle thinking on specific projects in New South Wales.
So Edge Environment is coming up to 9 years old now. I guess I keep saying 8, but 9 years old, and was basically founded on life cycle thinking. It was one of the core, skill sets and interests and passion of the founders of Edge. I've been with them for 4 years, and certainly infrastructure is a big part of our business, but it's only really a third of our business right now, and really taking that life cycle thinking from all sectors and applying it to infrastructure has been one of our real advantages and one of our real differentiators in the market. So in terms of infrastructure, we've probably worked on almost all of the major infrastructure projects in New South Wales at the moment, and even some in Queensland and Melbourne. So it's been a really steep learning curve, but also a really rewarding one where we can find innovative ways to apply life cycle thinking in sustainability and infrastructure, and apply that across all areas of sustainability as well, whether it's workforce, material choice, design, energy efficiency. And getting to a point now where even today, Jonas and I will be going to an interview for another major infrastructure project to try and help one of the big contractors to win a job as part of this Sydney Metro. So sustainability and life cycle thinking has really become a differentiator for these big contractors to win the large contracts to deliver this infrastructure. And in New South Wales, at least, there's infrastructure planning out to 2024 currently, and that doesn't even consider the rest of Australia. So we see that there's a real future in infrastructure development and sustainable infrastructure. So that's where we are now, and it's going to be an interesting and good ride for the future, I hope. So.
Yeah, great. It's very good to hear about all the in-depth knowledge that you have developed over the years by engaging with the industry, and also by working through difficult processes and so forth in infrastructure development in Sydney. I don't know whether I should ask this question from Ken or
I can take it. I think
you can take it. That'd be good. Can you just give us just an introduce life cycle thinking in a nutshell, in short?
Sure. So I think life cycle assessment you can think about as managing the whole value chain of a product or infrastructure asset or pretty much anything, tracing back from the cradle, where does thing come from, how is it manufactured, transported, used, and what happens with it at the end of life. So taking that holistic scope is at the core of life cycle thinking. The other aspect is the burden shift. So we want to optimize on several parameters. We want to get the best financial solution, the best social solution, and the best environmental solution. And it's about balancing those three and finding the right trade-offs and the right solutions to make sure you get the best overall outcome for the various stakeholders and for the client and for the operators.
Yeah, that's a very good description, and hope I can remember that, and then I can repeat it somewhere else. But the next question is about the term life cycle, because that's as soon as you hear life cycle, you think you always thinking about a cycle, and is it cycle or circular? And when it is a cycle, it has a beginning and an end, and if it is circular, then it just goes round. So can you please tell me or tell us now these different approaches to life cycle, gate to gate, cradle to grave, cradle to cradle. And I think you mentioned in your speech that now we are moving towards cradle to cradle rather than the other descriptions that we spoke about. But probably at the beginning of life cycle thinking, it was mainly cradle to grave. Yeah. Can you tell us how are we moving towards cradle to cradle now? And is it getting more popular? Whether it is practical to move on to that in terms of costs and time it takes.
Yeah, I think the concept started, as you say, from the aspiration to go to cradle and be circular. But there is a challenge. If you look at specifically, say you produce a steel product, for example, to take a cradle to cradle approach can be quite difficult because you need to trace back your supply chain and find out where everything's coming from to the manufacturing. And then all the uncertainty about, from the steel manufacturer's perspective, how is this product going to be used? In what application? What's the lifespan of this steel? It could go into a can, it could go into a steel rod or reinforcing concrete where it's going to sit for 100 years. It could go into a car or a train. It's expanding the cradle-to-cradle approach requires you to understand where the product is going to, traceability, and also the organizations and stakeholders involved in ultimately finding a home or a reuse or recycling opportunity for it at the end of life. So it requires a lot of collaboration between organizations and between jurisdictions and entities, which is why it's challenging. But with more interest and uptake and data and tools and mechanisms and frameworks to do this, it's growing in importance. And we are now seeing more and more real initiatives that are cradle to cradle and circular, rather than what it was a couple of years ago, more an aspirational concept.
I think even just to add to that, with some of the infrastructure projects that are going on now, 10 years ago, you wouldn't see the investment or the thinking or the resources applied into looking at the supply chain. And a contractor now is really expected to look back into their supply chain, not only to pass the contractual requirements on, but also influence and engage and share knowledge with their supply chain, so that a big contractor or a tier 1 contractor is then influencing tier 2, tier 3, right down to the SMEs about the environmental impact of the product or service they're providing, so that when they're putting together or building an asset or a building, they feel confident that what's gone into it from the cradle to gate is well managed, and then they can operate it till the end of life and have a plan at the end. So all these stakeholders are coming together and working together now. So it's very exciting, and it's a big change in the last decade, and specifically in the last 3 years as Jonas.
Yeah, I mean, you mentioned the term end of life, but cradle to cradle there is no end of life. And it is based on the scale of analysis. And then I know there are two main analytical types for life cycle analysis. So one is the process-based analysis, and the other one is input-output based. So in terms of this, whether it is circular or whether it is cyclical approach, and do you think that those two have different emphasis or different implications for the industry when you're doing it?
So, yeah, there are two different approaches to life cycle assessment, the process-based and the input-output based, and they're all very powerful and very useful, but they are different in what you have to pick one for a specific purpose and specific situation. So input-output is basically looking at the economic sectors and looking at monetary flow between industry sectors and countries, and mapping the associated environmental impact that flows with these transactions. It's very good for policy analysis, and if you, for example, are a major organization where you have thousands of suppliers in your supply chain, it's a good screening mechanism to find out where your hotspots are, where you should focus. But it doesn't give you enough information to make any design decisions or detailed solutions, because it's too generic. On a process LCA, you would work with different individual product types, different types of bricks, different types of concrete. Input-output, you would look at cementitious materials, metals as an industry sector without getting into the details. And it's not good enough to make decisions on metals. You need to know whether it's steel, aluminium, copper, not just what the sector overall is doing. So different applications. But there is a happy medium where you start with the overall input-output, which is quick and gives you the right focus. But then you start doing process-based on your hotspots. And that's called hybrid LCA, which is marrying the two.
Yeah, thank you. So there are other LCA variants. And I think it would be very useful if you could just give us a bit more examples on other variants of LCA analysis. And one of the very interesting one is EcoLCAs. And that is ecologically based LGAs. And the economic analysis, you just briefly mentioned that before. Can you expand on that a little bit?
Yeah, so I'm not very familiar with EcoLCA as a specific methodology, but I think I understand the concept and the aspiration of it, which is really about finding, when you do a traditional life cycle assessment, whether it's input-output based or process-based, you come up with an answer, carbon footprint of 10 kilograms per brick or whatever it is. It doesn't really tell you whether it's good or bad, or whether it's good enough, or where it needs to go. So to put this ecological carrying capacity to it and give it some boundaries and give it some limits is what this is all about, to monetize environmental impacts, to get them into the decision framework, as we mentioned before, but also to say, put a relative scale in terms of where we need to go to in terms of carbon mitigation, resource use, and get to more of what's actually can be defined as a suitably sustainable product or sustainable asset. So I think that's the balance, an EcoLCA concept applied more about carrying capacity and interpreting the life cycle assessment.
So you must have applied some of these approaches to real life. And can you briefly tell us which one would be more appropriate to infrastructure projects? I mean, such as North Connex or West Connex or our Light Rail or Sydney Metro.
So right now in the infrastructure projects, the way LCA is used is primarily in design. So when they're making a design decision around a particular material to use, whether it's a cladding or a roof on a bus stop or a train station, or renewable energy and where we're going to put renewable energy, solar cells or anything like that, it's primarily around design decisions. So if we were to say choose timber for a particular cladding on a wall versus stainless steel, what is the environmental impact of the two over the life, including maintainability, the production, the transport, the end of life options of those two materials? And the designers will then look at those options and compare it to other things like durability and cost and traditional kind of design factors, and it'll be used in the decision-making process to either implement or not implement that particular material. So it's very much used in a decision-making context right now. I think where it's going to go is it's going to go hopefully into planning type decisions for infrastructure and stuff like that. So a lot of these decisions are made at a high level up front, and then we leave the designers to do what they do best, which is to innovate and create the most efficient design possible with the best materials and the lowest impact.
Yes. And I have been thinking about environmental impact assessment, and the life cycle assessment is all about environmental impact. And one of the advantages of looking at the life cycle is that you have the ability to look at a range of impacts, whether they are minor or major, but because you are linking these impacts to the life cycle, so you have a better capacity to look at it or analyze it. Is that a fair statement?
Yeah, absolutely. It's the challenge with life cycle assessment, and as I mentioned before, is not to get stuck in talking about environmental improvements in isolation, but that connect it to, again, the triple or sometimes quadruple bottom line outcomes. But you need to find a way to manage different types of life cycle impacts. So mentioned in the presentation that a life cycle assessment typically includes up to 15 different individual concerns that we're trying to track. And we can't always have option A and option B, and option A is better in all the environmental impacts. You need to find a way to trade off and normalize and see the relative scale of which one is really the main pressing environmental concern here, and get the hotspots and the balance right. And there's various ways to do this in LCA. One of them is to connect it to something that's an endpoint, the end result on human health, the end result on ecological quality, the end result on resources, and bring it down to those three distinct measures. Or to find a way to normalize each individual midpoint of these 15, 20, and then weigh them individually to say, well, actually, I think climate change is more important than acidification, for example. That's a bigger challenge for us in Australia and globally. I'm going to put more focus on that. So there are different ways to interpret. And overall, when it comes to life cycle assessment, it's pretty pointless to do the analysis without digging into to verify your data, to look at the sensitivities and the scenarios, and actually understand what's going on, and understand what can I influence and what can I do.
I think just adding on to that as well, I think your kind of link with environmental impact assessment is quite clever. It does go beyond environmental into social as well, but I think the way to look at it is it's extending the environmental impact assessment beyond the footprint of the asset. So going into the impacts that were produced before the asset was even built. So if you can think about it that way, I think it's quite a good kind of way to visualize it.
Yeah,
So.
I just want to ask you just one single question, which is going to be very useful to our students to understand how life cycle thinking is working in the field. So you take one or two impacts, energy use or water usage. It's very simple, straightforward. And how do you use those elements in your analysis? Just exemplify that by using an example from an infrastructure project.
So typically it's good to bring it down into a few discrete measures, because that's typically what people can relate to. They can't juggle too much. They need to talk about carbon, energy, and water, maybe waste. That's what really has the front of mind for most people. But how you work on that is you need to drill down into each of this. It's probably not answering your question directly, but you can look at different design scenarios and different design options for an asset, saying we're going to build this rail line, for example. We're going to use this amount of energy that goes into the materials, that's going to be embodied in the structures and in the rolling stock. And we're also going to use this amount of energy to run the trains over 50 years, for example, and replace and maintain. So you get an energy balance and an energy footprint. But then you need to do the next layer of analysis and say, well, yeah, we want to minimize energy, but what we're really concerned about is possibly how much non-renewable energy goes in here. What's not from wind farms or biomass material or solar, what's fossil fuel based, and try to get to those first and minimize those first before we start to minimize the renewables. And in terms of water, you would look at where does the water come from, because the water footprint will be drawn from all around the globe, because it's a global supply chain. Where's water scarce? Where do you want to minimize water usage first? It's no point going to minimize in Tasmania, where water might be abundant, and rather focus on the water that's drawn and used in South Australia, for example. So that's the next level of analysis, to understand where the impacts come from. And then to potentially, as we mentioned before, to trade them off. Maybe you can't have both. Maybe you can have a lot of renewable energy, but it's going to be from hydropower. So, maybe there's a trade-off to be had. And at the end of the day, and it comes back to every life cycle thinking scenario, every life cycle assessment, it comes back to the first question you ask: what's the goal of this? Why am I doing this analysis? What am I trying to achieve? And what is the scope? So every life cycle exercise starts with a goal and scope setting. And if you get that right, that I want an energy optimized asset, that's my number one priority, that flows through in all the decision making and all the analysis afterwards. But to go into life cycle thinking and life cycle analysis without very strict and clear goal and scope in the beginning is pretty pointless.
Yeah, that really creates another question in mind. When you're talking about scoping, who are involved in this process, scoping process? Do you have a large number of stakeholders, or you only talk to your client?
Typically it depends on the asset, but I guess so. For example, if we take a simple infrastructure asset like a road widening or a new road, for example, which is essentially concrete road base, asphalt, and then maybe some lighting. We would engage with an understanding of, first of all, what is the client looking for? So not our client, but our client's client, so the government entity that's building the road. What are they looking for in terms of sustainability? Are they looking for a whole of life aspect and reducing the whole of life impact of the asset? Are we going into operation? If so, how long into operation are we going? So we're starting to get the scope defined through the entire contract, really, and the entire purpose of the road. And then we'll look at what's going into this asset. So for a road, it's essentially materials. If we spend 90% of our time thinking about how to save water in the production and in the construction and the operation of a road, and we don't think about the materials, then we're already going down the wrong path. So typically the first thing we'd look at is do an overall model of where the hotspots are in that road construction and operation. And then we would start to focus on those hotspots, and we would engage pretty much the entire project team, from design, constructors, material suppliers, estimators. We probably the least consultation that we would have is with the environmental manager, because they're already on board. So it's about really widening the net to get as much information and data as possible, so that we can focus on reducing the impact of the asset in the most efficient and logical way possible.
And also, a lot of these audiences include marketing and communication. They need to be involved in order to talk about what actually been achieved and provide knowledge sharing and lessons learned, etc. So surprisingly often it's driven by communication and marketing, that they want to be able to articulate and understand what's going on here, what did we achieve, and how can we back up our story. So yes, the engineers and the technical, but also the communication side is important.
Thank you. I think we've discussed sufficiently to give a very good understanding of the benefits and how it is done, benefits of LCA or LC thinking. And I have a couple of questions about the weaknesses,
The
challenges of LCA thinking or life cycle thinking. The first thing is about the labor intensiveness, or the time and energy required to collect information, maintain information, and ensures that the system in place that continuous updating of information is there. Is that a huge challenge where the resources are very limited nowadays?
It used to be, but I dare to say it's not a major challenge anymore. Life cycle assessment and life cycle thinking feeds off third-party information, because by definition you don't know enough about what goes on at the upstream and downstream of your focus. You rely on third-party information and third-party data. But there's a wealth of data available now that's been built up over decades internationally and in Australia. And utilizing this in a smart way really saves time. And also benchmark and understanding from previous projects where to look and where to start and not reinvent the wheel really saves time. So when life cycle assessments that feed into life cycle thinking used to take months and years, they can now be done in a matter of days and weeks, because there's already these default factors and lessons learned and benchmarks available to get you to the information and insights that you need and that you want. So we're probably going to carry that cross for a long time, the labor intensiveness and time consuming of doing this, but I would challenge that and say that technology and information has caught up, and that's no longer a major issue.
Yeah, I think life cycle assessment, even the terminology has got a connotation of technical, complexity, and of course it is, and it can be, but we also are, getting better and better at doing these things, as Jonas said, and if we think about the cost of doing an LCA compared to, say, the cost of the amount of money that's spent in advertising and marketing products, it's really quite insignificant. And what we're starting to see is a lot of building products and materials producers starting to do LCAs as a differentiator to provide a value for their products and provide the information to potential purchasers of that product, and it becomes a marketing kind of a marketing aspect of it, where the budgets that people spend on marketing far surpass what's spent on you would know in terms of research and technical value. So I think as it becomes more and more mainstream, it's going to become less and less cost prohibitive and more business as usual, I think.
Yeah, that's a very good news, because that has been the major stumbling block for applying LC thinking to major construction projects. And also there's another criticism, even though that things are improving in terms of databases and the cooperation between institutions of sharing knowledge and so forth, still it runs into thousands and sometimes millions of dollars to run a life cycle analysis. Can you comment on that? Is that getting better as well?
Yeah, I think so. I mean, it's the cost of doing it. The first time you do it, it's going to cost more, because it's more of a research and development exploration to understand. But as you become more and more refined, the cost goes down in terms of collecting the data and organizing the data. And at the end of the day, we want to come to informed decision-making tools and rules of thumb and guidelines, rather than having to do an assessment every time. So by learning more and collaborating, an industry collaborating and sharing, we understand better what's important and what matters, and we don't have to investigate every time. You make the decision once for this particular building, for this particular asset, in this location, in this use scenario, this is a good solution, and you start looking at the next frontier and explore other areas. So I think that's one way where it's becoming mainstream and really integrated into the way we do things.
So the other side is the value that it creates now is becoming more and more valuable, because the costs are coming down, but that information is becoming more valuable as environmental externalities are becoming priced more and more. We're seeing carbon being priced, we're seeing costs of fossil fuels going up, and it's not just a label and transparency, it's understanding your product more to be able to maybe future-proof it in the future, and understanding where you can reduce your impacts, which might not only be environmental impacts. Those environmental impacts might actually be cost impacts in the future as well. So I think the value of doing an LCA is also increasing more and more, even since the Coca-Cola example. So
That's a great example.
Yeah.
So are there simplified versions of LCA? You can introduce different levels of LCA depending on how important the project is or how much money is available.
I think it's not so much when you want to have informed decisions early on. You have to work with preliminary data, and you have to work with fast, short timelines, because that's fit for purpose for what you want to achieve at that particular stage. Now, when life cycle assessment and life cycle thinking becomes a bit onerous and expensive, is when you want to be able to make a comparative claim to say Coca-Cola is better than Pepsi. You have to be able to back that up quite rigorously, because it's affecting the marketplace, and it's a means to compete. That's when you have to go really deep and involve a lot of review process, etc. But if you want to use it inside our four walls for decision making and design decisions, and as Ken said, quick this material, it can be applied at an appropriate level, at the scoping level, as we would say, because doesn't have to take the scrutiny of the of competing of competitors, or you're not making any assertions in the marketplace.
Is that a fair conclusion to say that even though there has been improvements in bringing down the price or less low cost and improving databases and so forth, still taking up life cycle thinking in projects is quite low?
It is, because as Ken mentioned as well, it's driven by the client. It's driven by, they're not going to do it often because of the timelines and budget constraints. They're not going to do it autonomously. That it needs to be pushed and incentivized somehow, and we see that incentives being driven very much by clients, but also it's the general knowledge in the marketplace about the benefits, which only really becoming really apparent now the last couple of years in terms of the business case, saving money, as Ken talked about before. Like, that's ultimately what's going to drive this.
Yeah, and I think it's, as Jonas says, if Coca-Cola and Pepsi are going to compete each other and do a life cycle assessment, then those sorts of things are probably still maturing and still kind of growing, and there's some ways to go there. But in terms of, I think, life cycle thinking on a project, in terms of applying the theory on an infrastructure project, I think there's a lot happening that's not labeled as life cycle assessment, but it is actual life cycle thinking. So, last week I was at Castle Hill for Northwest Rail Link, giving a presentation to their whole supply chain. 100 people were there listening about how they can manage their impacts and also their suppliers' impacts. So to me, that's already some life cycle thinking being applied in the delivery and the procurement of a project. Yes. Things like workforce thinking. There's big changes going on in terms of providing a lasting legacy of workforce for all these projects in the local areas where they're happening. Why should we build an airport out in the southwest and not benefit the local community and upskill the apprentices and the disadvantaged and the youth and the population there? Why should they not benefit from this development and get the learning so that they can then take their skills elsewhere? So I think that in itself is a life cycle kind of thinking of the application of life cycle on a project, but it's not necessarily a life cycle assessment. So I think the thinking is really growing really quickly, but the actual label of life cycle assessments is maybe evolving as well. So.
I think that's something very good to hear.
Yeah.
I think that's what the world need. We all need to think on those lines, life cycle thinking, and in our sustainable infrastructure course, that's what we're trying to impart to our students. Whatever we do, we need to adopt this life cycle thinking, particularly in infrastructure, which uses enormous amount of resources. But just to wrap up our, very interesting conversation, just want to ask both of you, just to comment on the future of life cycle analysis. And what do you think the LCA method is improving? It's far always, as you carry out one analysis, then how can you improve these analytical methods. So are there enough research is done? Are there enough discussion going on about life cycle thinking across the industry and amongst academics? And particularly when you're talking about academics and practitioners, there is a belief that life cycle analysis and life cycle thinking is more technical oriented, as you mentioned before, Ken. And particularly they think that it's an engineering tool. But as I now learn, it is not just engineering, and it is a life cycle. So life cycle has got so many different aspects. So in terms of going forward, are we being very broad-minded in looking at LCA method?
I think what I'd like to see going forward is, I guess, more integration of this thinking, whether you're buying concrete to build a massive metro railway, that both the concrete provider and the concrete purchaser are thinking beyond their four walls. I'd like to see, having a life cycle assessment being done as a differentiator between product providers in the construction industry and also the suppliers actually going beyond cost in terms of their four walls, in terms of, we're buying this piece of concrete for the cheapest possible thing, when 10 years down the road there might be some issues with it, that they're thinking along the whole life of the asset. And I believe it is slowly happening, and it's definitely happening quicker and quicker, especially in the last 3 years, and I'm confident it will happen. But I think there's still a gap between the different stakeholders in terms of the building products manufacturers, the contractors, and the proponents that are building these assets, whether they're operating them and whether they're public or private. I think those three people or three stakeholders really need to kind of connect the dots, because they're all doing individually very good work and trying, really, I think they're honestly putting some good investment into this. But where we need to work on is the links between those stakeholders, I think. So
Yeah.
I'd like to see that as the future of LCA and infrastructure anyways.
Okay, thank you. Jonas?
Yeah, no, I agree with that. That's collaboration aspect, and the supply chain management and managing the value chain is really important. But and I think I alluded to it before as well, that life cycle assessment has a role to play, but then it needs to be institutionalized. The lessons learned and the findings needs to be brought into the way we do things. So rating tools, for example, infrastructure sustainability rating tools should all be life cycle thinking based, so that all the requirements, regardless how you break it down, it's all based on this overall holistic life cycle thinking view. So you start with an overall optimization aspiration, and then you write the individual requirements as such. And the clients, and when they design projects, they need to have this life cycle triple bottom line starting point, that's what they want to achieve. All the way down to product certifications. When you say, how do I qualify this, how do I give this product, this concrete product or steel product, an eco-label? Well, the requirements should be life cycle based, but the product might not need to go through a life cycle assessment because the requirements are already incorporated, that thinking. So there will always be a role about kind of getting a competitive edge by linking and finding smarter ways to collaborate, but at the same time, let's eliminate the redundant work and kind of write all the top level, outcomes and requirements from this broad perspective, and get the direction right. Because as we know, it's in the first design meetings, it's in the planning stage where the big impacts can be had. And I was actually, we have to talk about food. We have to continue talking about food. I was in a meeting the other day about where a restaurant firm met with a packaging firm, and they talked about the restaurant firm came in and said, we want sustainable packaging on our products, and can you deliver that? Ideally biodegradable. And the packaging guy, they said, again, they come up and they say, we have these food products, give us a sustainable packaging. Why can't we be there in the beginning when you design the meal, when you design the product? Why does a hamburger need to be round? If we can be in there, we can optimize the overall solution. I thought that was great, and that applies to infrastructure as well. As Ken said before, chickens and infrastructure is the same thing.
That's very. I mean, that's the beauty of life cycle thinking, and it was interesting. I had that conversation yesterday actually with one of the major contractors, and they said, oh, you guys do work with chickens. How does that even apply to roads? And I said, well, it's the same thing. When you look at it, it's still a product. It's still it's an asset to society.
Yeah.
We can look back into its life cycle or look forward into its life cycle, and we can manage appropriately. The theory is the same, whether it's infrastructure, chickens or hamburgers or chocolate bars or whatever. It's just about applying a little bit more than what's within your bandwidth currently. So I think I think there's a future for it, because anyone can measure their footprint now.
Okay, on that note, I'd like to conclude our interview. But first of all, I would like to thank both of you, giving your time so generously. And also, I'm really privileged to welcome you back to UNSW again.
Yeah, we're both alumni. So,
so I think it has been real pleasure talking to you all both.
Thank you, sir.
Yeah, thank
Yeah.
you.
Thank you very much.
Thank you.